All right, so there is a special request to get a little bit more instruction on graphing from vertex form and also changing from standard into vertex form. So I'm just going to do another little instruction. First, this is the vertex form. It's called the vertex form because the vertex of this parabola will be the point h comma k. And then we use the A rule to graph from there. So I'm just going to make something up. We're going to graph something. How about y is equal to 2x minus 1 quantity squared plus 3. So this is a parabola already in vertex form. If I wanted to sketch a graph of this, I know my vertex, this is h. H is 1 and k is 3. So my vertex is the point 1 comma 3. So if I put a couple of slash marks down here, 1 comma 1, 2, 3, here we go. And then I use the A rule, the A is 2. So from the vertex, I'm going to move 2 to the right and then up, I'm sorry, 1 to the right and up 2, and 1 to the left and up 2. And we should be able to give the coordinates of this point. So if this point is 1 comma 3, this point would be 2 comma 5. And this would be 0 comma 5. So that's the HK. Let me change the signs around a little bit and do another one. How about y is equal to negative 3x plus 2 quantity squared plus 1. So you always want to identify the h and the k. Now look at the form. Do you see how it's minus h? So h is a negative 2. You can think about it as just saying, well, it's got to be the opposite. Or you could think about a plus being a negative negative. That confuses most people. So I usually just say, go the opposite for the h, and then the k is what it is. So our vertex for this will be opposite, negative 2 comma 1. And then our a is negative 3. So let's go ahead and do this. So let's go to negative 2 comma 1. There's the vertex. Now we apply the A rule. From the vertex, we go 1 to the right, and then we go down 3. 1, 1, 2, 3. So this would be the point negative 1 comma negative 2. And then go back to the vertex, go 1 to the left, and down 3. 1, 2, 3. So this would be negative 2 comma negative 2. And then we have sketched our parabola. So these are supposed to be pretty much the easier ones. The harder ones are to convert from standard to vertex form. So let's just throw down. It's always easier if your B term is an even number, right? So let's do 6x and then do some random minus 5. So we want to convert this to look something like that. What we have to do is we have to complete the square. When we complete the square, we're looking at these two terms. This is our junk number. So we write x squared plus 6x. Our junk number goes off here to the side. Our perfect number, to make this a perfect square trinomial, this number must be half of this, which is 3, and then square it. So we need a plus 9 so that we can factor this into x plus 3. So this is tricky, right? We've manipulated this so that we can factor it into this. Do you see what we're trying to get at? All right. Now we can't just go ahead and adding 9 to an equation. We have to balance that off by subtracting the 9 here, because in essence this is 0 now. 0 is what we've applied to this side. That's cool. these two numbers become the k. So -5 and -9, our junk number plus opposite of what we did here would be a -14. And then now if we had to graph this, our vertex would be the point, opposite this always, -3, -14. And our a is 1. So if you wanted to graph that, you go somewhere down here and sketch it. I'm not going to take the time to do it. All right, let's do another one. How about y equals x squared? Let's do a minus this time, even number, and then random number. Alrighty. So we're only looking at the x squared and the -4x. This is junk. Perfect number is half of -4, which is -2, square it, +4. I hope you see that this number that we add in, our perfect number, will always need to be positive. Whatever we do here, we have to do the opposite over here to get it balanced, right? This factored, now our middle term will be minus because this middle term is minus. This perfect number is either half of this or the square root of that, which they both happen to be 2, right? All right, and then add those together, -3. Y equals, what's our vertex? +2, -3, if you had to graph it. Do you want to see one more? Y equals x squared, random even number. How about -8x? Just whatever else here. How about +3? Standard form. We're only looking at these two guys. We're ignoring the +3. The perfect number, what do you think it is? Do you know how to get there? The perfect number is half of b squared. I hope you said that's 16. Since we added in there, we have to subtract it at the end. I haven't been writing in my y equals, but it's still there. How do we factor this? We're going to have an x. We're going to have a minus. This number here is the square root of 16, which is 4. It's also half of this number, which is 4. Combine these, -13. Just for fun, I'm going to actually multiply this out, and you can see that we'll get back up to here. This is equal to this. How is that so? Well, x minus 4 quantity squared would look like this. Let's FOIL x squared minus 4x minus another 4x plus 16. Now let's combine x squared minus 8x, 16 minus 13 is +3. Do you see? They are in fact equal. You just need to practice some of these. If you like more practice, you could probably hop on Khan Academy and look for completing the square under either Algebra or Algebra 2. All right, I hope this helped you out.